Before diving into the logarithm, let's start by recalling indices. So if you have a number like this, basis, if you remember in indices, if you have a basis like this is our base raised to this power, which sometimes is called index or exponent. So if you remember, whenever we have b to power p, it means you have to multiply b by itself p times. So for instance, if you have 2 power 3, 2 raised to power 3, it means this base 2, you have to multiply it 3 times by itself. So 2 times 2 times 2. So which is 2 times 2, which is 4. If you multiply the first 2 times 2, and 4 times 2 is 8. And if you have a 4 square, that is 4 raised to power 2, our base is 4, our power is 2, it means you should multiply 4 by itself twice. So this is 4 times 4, and this is 16. Now let's get back to logarithm. Imagine you have a 4 raised to power p will give you 16. So you know the result, you know the base, which is 4. So this is our base, and this is our result, and we don't know the power. So this is where the logarithm comes. Logarithm is just like the reverse of the indices. So it's just when you are given the base and the result, then you want to find the power. So we'll just see the log of our base is 4, and with the result 16 is equal to this p. And in this case, if you remember, uh, if we say 4 power p is 16, it means 4 times some times itself at sometimes is equal to 16. So if you remember, if you start, we can start by maybe 4 times 4 and see this 4 times 4 will give us 16. And 4 times 4 is just 4 twice 4 square. So then this, I can write it as 4 raised to power 2 is equal to 16. And in logarithm, I will write log this 4 and this 16 is equal to our power, which is 2. So that's why in general we have this formula. So if you have b raised to power p, your base b power p, n is just the same as log of n with base b is equal to p, your power. So let's do some example and try to find the base. So the first one is this 2 power 3 equal to 8. So let's convert this into the log form. So for this one, we know that our base is 2, our power p is 3, and our result n is 8. So if you want to convert it to the log form, if you look at it here, it's just log of our base is 2 and our result n is 8 is equal to 3. So that means 2 raised to the power of this. This means this 2 raised to the power of this 3 will give you 8. Next example, we have 3 square raised to the power 2 equal to 9. So if you look at here, our base is 3, our power is 2, and our n is 9. So this is just saying the log of our base, which is 3, and our result is 9, then 3 power 2, because 3 power 2 is equal to 9. Another example, here we have the log form, and we want to convert it to the exponent from the indices. So for this one, if you look at our n is, let's start with b as usual. Our base is 5 here. Our p, that is our result. Our power is 3, and our n is 125. So this one we can just write it as in this form: b power p, that is 5 power 3, is equal to 125. So, and remember, 5 power 3, this is just 5 times 5 times 5. If you multiply it, 5 times 5 will give you 25 times 5, and this will give you 125. Now we will discuss common log and natural log. Common log is usually written as a log without the base, and this is just means log 10. So whenever you see a log, for instance log 200, this just means log 200 base 10. The base 10 is there, and we use this because in our decimal number system we have a 9 digits, 0 1 up to 9. So whenever you see log, it means a log with base 10. The next is natural log, which is ln, and this ln is means log e, log with base e, where e is the exponential and it's approximately equal to this. And you will also find this in your calculator, and log and even this ln. So let's treat some examples. So the first example is you are given this log 1000 equal to x. So you know this is just log. Since we don't have a base, it means log this is equal to x. And remember, whenever we have log of base b and with this p, this is just b raised to power p is equal to n. So if you want to write this one is in that form, here this is our base and this is our power. So then we can just see 10 raised to power x is equal to 1000, and the 10 raised to power x is equal to 1000. Then we can try maybe 10 times 10 and see, since 10 raised to power x is 10 times it itself, 10 times 10 times 10 is 100. This is not 1000. Then we can add maybe this 10 times 10 times 10, and this is just 10 times 10 is 100 times 10. This is 1000. So this is 10 3 times, that is 10 raised to power 3 is 1000. So then from this one we can see our x is 3. So this implies that our x is 3. So you can just write log of 1000 base 10 is equal to 3, because what? 10 raised to power 3 is equal to 1000. So in this example, we will solve ln of e equal to x. So the first step is we remember that whenever you have ln, this ln is just the same as log e. So we'll replace this ln with log e. So we'll have a log e, then we put this e. This one is, instead of ln, e equals x. And from our rule, we know that whenever we have log of n with base b is equal to p, or power p, this is just b raised to power p is equal to n. So that implies that this one, this e is our base and this x is our power. So then we can just write it as this e, our base, raised to power this x, should be equal to this e. And if you look at this, e power something is equal to e, that means the only thing you can is e power 1, that will give you e. So then we can just say our x equal to 1, and this implies that ln of e is equal to 1.